Good morning children. Today we are going to learn another lesson in chemistry is nothing but air. We studied about in the lower class about air, that air is made up of various gases which surrounds the earth planet. We cannot imagine a life without air. Each and every living organisms need air to survive. Air consists of 78% of nitrogen. So we have studied the components of air. What is the compositions of air? We have 78% of nitrogen, then 0.093% of argon, 21% of oxygen, 0.04% of carbon dioxide, and some amount of gases also present in the air. So here we know that the human beings or the living organisms take in oxygen and give out carbon dioxide, whereas plants take in carbon dioxide and give out oxygen. So here what happens when we cut down trees, the level of the carbon dioxide will be more in the environment, which causes various effects. So in this lesson we are going to learn about the various effects like greenhouse effect as well as the global warming. And also we are going to study about the occurrence and properties of gases like oxygen, nitrogen and carbon dioxide. So we are going to learn about first gas is nothing but oxygen. So no living beings in the world cannot survive without oxygen. Every living being needs oxygen to survive. Even the small insects also need. The fishes also need the dissolved oxygen so that they can survive in the world. So here the oxygen was discovered by the chemist, that is Swedish chemist called Scheele in 1772, and the other chemist also found, his name is Joseph Priestley in 1774. That name oxygen was coined by a person called, by a chemist called Lavoisier. He only gave the name as oxygen. Here oxygen is taken from the Greek word oxygenous, that is which is called as acid producer. That is, it was thought that the acid is produced with the help of these gases. So now we are going to see about the occurrence. So the oxygen is the most abundant element on the earth, and it is the third most abundant after the helium and hydrogen present in the universe. It is also present in it is mainly produced by the plants, where I said during the process of photosynthesis. So during photosynthesis the plants take in oxygen, which reacts with the chlorophyll which is present in the leaves with the solar energy and gives out oxygen. That's the thing we are saying. So it takes in carbon dioxide and gives out oxygen. And also it is present on the water surface. We can see in the water also the oxygen is present. And also it is present in the land, like minerals, like it is present like a minerals in the landforms, like what we say is metal oxides. As a metal oxide is present in the land. In the water also oxygen is present. On the surface of the water oxygen is present. It is present as a diatomic molecules in the, when you write an oxygen, we will write as O2. So in the atmosphere it is present as a diatomic molecules, and a triatomic molecules we call as ozone with the formula O3, which is present in the atmosphere, which is useful for protecting as a UV layer which is radiated by the sunlight. So these are the occurrence. So we can see the oxygen is present everywhere in the land as well as in the air as well as in the water. So now we studied about the occurrence. So we studied about who discovered and why the name is given. And also I would like to say that it is given as a fire gas because it supports a combustion. So that is the thing, it is given named as fire gas. The next we studied about the occurrence. As I said, it is occurred in the land, air and water in various forms. In the land it is present as a metal oxide. It is present as a metal oxide. In the water also the oxygen is present. In the air also it is present as a diatomic molecules. It can be in the combined state or in the free state. This is a thing. The next we are going to learn about the properties of oxygen. So properties, when I say about properties, oxygen is a colorless. So I am writing the properties. It is a colorless, odorless, tasteless gas. So oxygen is a colorless, odorless, no smell at all, and tasteless gas. It is a non-supporter. So it is a poor conductor of heat and electricity. Oxygen dissolves in cold water. That's the thing. It is readily dissolves in the cold water. That's why the fishes can able to take that dissolved oxygen for their respiration. And it is denser than air. It can be made into liquid at high pressure and low temperature. It supports combustion. So these are the properties of oxygen. So I repeat again, oxygen is a colorless, odorless and tasteless gas. It is a poor conductor of heat and electricity. It is readily soluble in cold water, as well as it is denser than air, and it can be liquefied at high pressure and low temperature. It supports combustion. So these are the properties. So we studied about the occurrence, about what is the introduction I given about the introduction of oxygen. So who discovered, who named, why it is named so, like that, all these things we studied. And also we studied about the occurrence, so where it is present, how much it is present, everything we studied. And also we studied about the properties of oxygen. Now we are going to see the next topic is nothing but the chemical properties. So far we studied about the physical properties. Next we are going to study about the chemical properties of oxygen. So chemical properties of oxygen, the first one is combustibility. So as I said, oxygen is a non-combustible gas on its own. It does not burn on its own. It is a non-combustible gas, but it supports a combustion. You can understand the meaning of this because it won't get fire, it won't catch fire on its own. It can support to make the fire to get it rapid. That is the thing. So oxygen is a non-combustible gas. It does not get heated by itself. It cannot burn on itself. It can support the combustion. That is the meaning of combustibility. So it is a non-combustible substance, but it supports combustion. So this is the meaning of that. I hope you can understand what I am saying. So this is the thing. So oxygen is a non-combustible gas, as it does not burn on its own, but it supports the combustion. When other elements burns, it also makes them to burn very rapidly and very freely. That's the thing, meaning of this. The next is reaction of oxides. Reaction with oxides. Reaction with metals. Please make a change. Reaction with metals. So oxygen combines with metals like sodium, aluminum, magnesium, iron and so on. It produces metal oxide, that is respective metal oxide will be formed. That is called, we can say as when sodium Na is reacting with oxygen, Na is reacting with oxygen, it gives metal oxide as Na2O, that is sodium oxide will be given. So that is the thing, when metals like sodium, potassium, iron, magnesium reacts with oxygen, it gives sodium oxide or metal oxide. I can write here metal plus oxygen gives metal oxide, which are basic in nature, So the first reaction is nothing but combustibility. The next reaction is studied about reaction with metals. The third reaction is nothing but reaction with non-metals. So this is third reaction. Reaction with non-metals. When the oxygen reacts with the non-metals like calcium, phosphorus and so on, it forms non-metallic oxides. So non-metal plus oxygen gives non-metal oxides will be formed, which is acidic in nature. So we studied about the three reactions is nothing but reaction with combustibility, reaction with metals and reaction with the non-metals. I need everyone to have the book in your hand. Just go through the tabular column which is given. You can see it depends upon the temperatures also when it reacts with the metals. So reactivity of oxygen with metals is given in the tabular column in your book. You just have a look of it. For example, the first metal they given as K. K is nothing but potassium. The symbol for potassium is K. The temperature should be at room temperature. At room temperature itself it can able to form the product like potassium oxide. The next is Mg. Mg is nothing but magnesium. The symbol for magnesium is Mg, and when you heat slightly it forms magnesium oxide. The next symbol is, the next metal is calcium. So Ca is the symbol for calcium, and the temperature will be heating slightly. If you heat slightly it can produce calcium oxide. The next elements is given as iron. Fe is iron, Cu is copper and Ag is silver. So I repeat again, Fe is iron, Cu is copper and Ag is silver. When you heat it at a high temperature, it produces its respective oxides like iron oxide, cupric oxide and silver oxide. So Au is nothing but gold. The symbol for gold is Au and Pt is platinum. So with this there is no reactions even at high temperatures. It does not form any oxides even at the high temperatures. These are the metals reacts with oxygen to form its metal oxides. The same way reaction with non-metals, you can see carbon plus oxygen gives carbon dioxide. So I have given as non-metal as carbon. Please make a note. Carbon plus oxygen which gives carbon dioxide, which is a non-metallic oxides. So here also they gave a tabular column. What are the metals reacts with oxygen? It forms. So what are the non-metals react with oxygen forms non-metals like C is carbon. The products form is carbon dioxide, and N is nitrogen. It forms nitric oxide. Then S is sulfur. It forms sulfur dioxide, and P is phosphorus. Phosphorus trioxide, or it forms another oxide also, phosphorus pentaoxide. So I repeat again, we studied about the combustibility. As I said, it is a non-combustible gas which does not burn on its own, but it supports the combustion. It makes the objects to get fire easily. That's the thing. The next is reaction with metals. When oxygen reacts with metals, it forms metal oxides, which is basic in nature. And I have given some examples also. Here also I wrote an equation as Na plus O2 gives Na2O. I am just balancing the equation. 2Na plus O2 gives Na2O. And the next one is reaction with the non-metals. That is nothing but when non-metals reacts with oxygen, it gives non-metal oxide. So carbon plus oxygen gives carbon dioxide, and we have seen some other non-metals and metals how they react with oxygen and what are the oxides they formed. The next is we are going to see about reaction with hydrocarbons. So hydrocarbons is nothing but like the compounds which contains carbon and hydrogen as a compound is called hydrocarbons. So the fourth reaction is reaction with hydrocarbon. So when you heat hydrocarbons, it produces heat, it produces light energy, and it gives out carbon dioxide. So you can see here hydrocarbons react with oxygen to form carbon dioxide and water vapor. When it burns, it gives out heat and energy. So these are used as fuels. I'll write the equation here as hydrocarbon plus oxygen. It gives the products as carbon dioxide, then the product as water vapor will be there, and also it produces light and heat also will be produced. I can say a very simple example, petrol. Petrol comes under the compound hydrocarbons, because here when you heat it, you can see some black fumes will be coming out, that is nothing but carbon dioxide, and also it produces heat and light also. So we can say when oxygen reacts with hydrocarbons, it produces carbon dioxide, and the other products as heat and light energy will be exhausted, with the water vapor also will be evolved. That's the thing about this reaction. The next is rusting. Fifth reaction is rusting. We studied this rusting in our lower classes. When iron reacts with oxygen in the presence of moisture, that is in the presence of oxygen, when iron reacts with the oxygen in the atmosphere, which is present in the atmosphere, in the condition of moist, it produces a brown layered substance called as rust. We called as ferric unhydrated oxide, that is called as rust. So here I can just say the process of conversion of iron into hydrated form of oxide in the presence of air and moisture is called rusting. So rust is nothing but hydrated ferric oxide. Fe plus O2 gives Fe2O3. This is ferric oxide, Fe2O3. When this Fe2O3 react with in the presence of water, this XH2O tells there is number of water molecules will be present. Can be written as Fe2O3 XH2O. So this X is nothing but number of water molecules present. So ferric hydrated oxide, that is the meaning of this. I hope you can understand what is rust. So rusting is nothing but conversion of iron into hydrated oxide is called as rusting. So that's all about this chemical properties of oxygen. So we have studied 5 chemical properties. One is combustibility, next is reaction with metals, third one is reaction with the non-metals, then reaction with the hydrocarbons, and we studied about rusting. Now we are going to see about the uses of oxygen. So it is used as a oxyacetylene cylinder for cutting and welding metals. So when you go to the welding shops, you can see some gas will be blown, the cylinder will be kept. So that is nothing but oxyacetylene cylinders, where the oxygen also will be there, which is helpful for cutting and welding the metals. It is used to remove carbon impurities from steel. Plants and animals use oxygen from the air for respiration. It is used as rocket fuel. It is used for artificial respiration by scuba divers, mountaineers, astronauts, patients, etc. Wherever you go to the hospital, we can see the oxygen cylinders will be present. For if the breathing is very poor for us, immediately we use that type of cylinders for our respiration. Then mixed with the powdered charcoal, it is used as explosives. It is used in the synthesis of methanol and ammonia. So these are the uses. I hope everyone can understand the uses. I have gone through the uses, and you just revise what are things I thought. So I just recall what the topic we are dealing with. We are dealing with the lesson air. In that we are studying about gas called oxygen. Here we studied about who discovered oxygen, what was the name given, why it is named as such, as well as that's the introduction I gave. The second part we studied about the occurrence. We know that in the earth, wherever we go, oxygen is present. It is present in air, land and water. It is present as a diatomic molecules in the air as O2, and ozone is also present on the upper atmosphere, so which protects the UV rays of the sun. So these are things we studied in the occurrence. The next we studied about the physical properties. We studied about some points like oxygen is a tasteless, odorless gas. it is slightly denser than air, it is readily soluble in water, that is in cold water, it is a supporter of combustion. It can support the combustion, but it itself cannot catch fire, that is the thing, and it can able to be liquefied. It can be made as a liquid at certain temperature and pressure. So these are the things we studied in the physical properties. The next topic we dealt is nothing but the chemical properties. In that we studied about what is combustibility, how it reacts, that is, as I said, it is a non-combustible gas, it does not burn on its own, but it supports the combustion. It makes the things to burn easily, and we studied about reaction with the metals. Here, when the metal reacts with oxygen, it forms metal oxide. So, sodium, I took an example as sodium plus oxygen gives sodium oxide. The next is we studied about reaction with non-metals. So, when non-metals react with oxygen, it forms non-metal oxide or non-metallic oxide, which is acidic in nature. I took an example as carbon plus oxygen gives carbon dioxide. Like that, so many non-metal examples also given in the tabular column. You can have a look of it in your book. The next topic is reaction with hydrocarbon. Here, as I said, hydrocarbons is a compound which contains hydrogen and carbon in it, which when it reacts with oxygen, it forms carbon dioxide and water vapor, and also heat and light energy also will be exhausted. So, these type of things are used as fuel. So, I gave an example like petrol. Petrol is a fuel because when you burn it, you can see it will catches fire and it burns with the black fumes, that is nothing but carbon dioxide. The next is rusting. When iron reacts with water in the air and the moisture present in the air, it forms a ferric hydroxide. So, there is hydrated oxide will be formed, that is called as rusting. I already explained in the previous class also what is rusting very clearly. So, you need not explain more about this rusting in this lesson. I hope you can understand. And we studied about the uses of oxygen. Just have a look in your book regarding the uses of oxygen. The next topic we are going to learn is about nitrogen. So, next gas what we are going to learn is nitrogen. We know that nitrogen is very important, which is the most abundant. The percentage is more in the atmosphere. As I said, it contains 78% of atmosphere contains nitrogen. So, which is very important for the growth of living things. All the living beings need nitrogen for their growth. It is present in the proteins and nucleic acids in the human body or in the living organisms, which is called as building blocks of all the living organisms. So, the nitrogen is very essential for the growth of both plants and living beings. All the animals, all the human beings, whatever it is very essential for that. So, it was discovered by Daniel Rutherford. The scientist's name is Daniel Rutherford. Isolated nitrogen from the air in 1772. So, he is a chemist who found this nitrogen gas from the air. So, Daniel Rutherford, and he named the nitrogen, that is, this name is taken from the Greek word as nitron and gene. So, because it is taken from the Greek word nitron and gene, that is which produce, that is the meaning is I produce nitre. So, nitre is nothing but it is a potassium nitrate compound of nitrogen. So, that is all about the introduction about nitrogen. As I said, nitrogen is very essential for the growth of all the living organisms. Plants also need nitrogen for their growth. Occurrence of next the topic we are going to see is occurrence of nitrogen. So, nitrogen is the fourth most element present in the human body for our growth, as well as it is the seventh most abundant element on the universe. It is considered that the moon satellite called as Titan, which is the the natural satellite of Saturn, contains 98% of nitrogen in its atmosphere. So, this is the thing. it also occurred in the combined state as well as a free state. It will be in the combined as well as free state. It is present as diatomic molecules in the atmosphere like N2. When we write nitrogen, we write as N2, which is present in the atmosphere as a diatomic molecules. It is also present in the combined state in the form of minerals like nitrate and Chile saltpetre. It is present in organic matter such as protein, enzyme, nucleic acid, etc. So it is present, as I said, it is present in our body also for our growth, which is present in protein, which is called as the building blocks of the body. That's the thing about the occurrence of nitrogen. The next is physical properties of nitrogen. As I said, as an oxygen, it is also a colorless, tasteless, odorless gas. It is slightly lighter than air. It is slightly soluble in water. It can able to soluble in water, not as such as oxygen. It can also get soluble. Nitrogen becomes a liquid at low temperature and looks like water. So we can see the word liquid nitrogen. So we hear this word. So it can be able to as a liquid also. As oxygen, this also can be liquefied. When it freezes, it becomes as a white solid and it is neutral to litmus like oxygen. It is neither acidic nor basic, it is neutral. So these are the physical properties of nitrogen. The next is we are going to study about the chemical properties of nitrogen. So we studied about where it is occurred and about the physical properties. Now we are going to study about the chemical properties of nitrogen. So first reaction is chemical reactivity. So coming to the chemical reactivity, nitrogen is inactive or at ordinary conditions. So it needs a particular temperature to get activated. So it is very inactive at ordinary temperatures. It needs high temperature and pressure, or at the presence of catalyst only it becomes very active. So this is the thing. So I can write here inactive at ordinary temperature becomes active at high temperature and pressure, or in the presence of catalyst. You know what is catalyst? Catalyst is nothing but it is a substance which can improve the reaction, rate of reaction, but it will not take part in that reaction. That's the thing. This catalyst also we studied in the previous class. Okay, so I am not going to explain more about the catalyst. So this is the thing. So about chemical reactivity, it is inactive. Nitrogen is inactive at ordinary temperature. It will be active when it becomes at a high temperature or pressure or in the presence of catalyst. The next is combustion. So nitrogen is neither combustible or a supporter of combustion. So nitrogen in the air moderates the rate of combustion. It does not moderate the rate of combustion. It will not burn on its own. As I said, oxygen also is a non-combustible substance. It is neither a non-combustible or it cannot support this combustion also. It will be there. It will be moderate the rate of reaction. That's the thing. I hope you can understand. The next is reaction with metals. Nitrogen reacts with metals like lithium, calcium, magnesium. So the second one is combustion. Third one is reaction with metals. So metals plus nitrogen. The nitrogen, it gives nitrites, metal nitrites. So I can take the example as they given in the book. I can take Ca, calcium plus nitrogen gives calcium plus nitrogen gives Ca. So here we can write a Ca3N2, so 3Ca. It is balanced now. So calcium nitride is formed. The next reaction is reaction with the non-metals. Same here also. Metals react with the non-metals like hydrogen, oxygen at high temperature. As I said, both will happen only in the presence of high temperature to form a corresponding nitrogen compounds. Example is hydrogen plus nitrogen gives ammonia, H2. So I can write here, it will be easy for you to take notes. Nitrogen, it gives nitrogen compounds. So here you can write as hydrogen, N2 plus H2 gives, so this is nitrogen, this is hydrogen gives ammonia, NH3. When we balance the equation, you get as, it is balanced now. You can see the equation is balanced. So balancing equations you will learn elaborately in the next classes. So this is the thing. So reaction with metals and reaction with non-metals. When it reacts with metals, it forms metal nitrides. When it reaction with the non-metals, it forms nitrogen compounds. Both the things will happen in the presence of high temperature. So that's all about the chemical reactions. Now we are going to see about the uses of nitrogen. So please have your book with you. Liquid nitrogen is used as a refrigerant. It provides an inert atmosphere for conducting certain chemical reactions. It is used to prepare ammonia, which is then converted into fertilizers and nitric acid. It is used as a substitute for compressed air in ties. You can see when you go to the petrol bunks, you can see they will be given as N2. Nitrogen gas will be, the tanks will be there. It is used for filling the space above mercury in high temperature thermometer to reduce the evaporation of mercury. It is filled in the thermometer also. Many explosives such as TNT, trinitrotoluene, nitroglycerine and gunpowder contain nitrogen. It is used for the preservation of foods, manufacturing of stainless steel, reducing fire hazards and as part of the gas in incandescent light bulbs. So these are the uses of nitrogen. You just go through once so that you can understand by yourself. The next is we are going to see about the nitrogen fixation. As a small part is that we know that plants also need nitrogen for their growth. The plants cannot take the elemental nitrogen as it is in the atmosphere. We know that in the nitrogen is present in the atmosphere, it can't take as it is. So what these plants will do, the plants want the either soluble nitrogen for their absorption. The roots can absorb only the soluble nitrogen. So it goes out various process. So what is nitrogen fixation? Is nothing but any process that converts nitrogen in the air into useful nitrogen compounds is called nitrogen fixation. It can be done either by man-made or naturally. So naturally it can be done by leguminous plants. That is the pea plants. That is we call as symbiotic, the parasites which is present in the roots of the plants will be able to convert the nitrogen into soluble nitrogen compounds. So the leguminous plants and also in the lightning, the artificial fixation is nothing but from ammonia and ammonium salts, from nitric acid and nitrate salts. So by these two processes the plants can absorb. It can't take as such as in the atmosphere. It converts that nitrogen compounds into soluble nitrogen compounds for their use. This is called as nitrogen fixation. This nitrogen fixation is done either manually or naturally. This is the thing about the nitrogen fixation. I hope I have taught you about the two gases. One is about oxygen, the occurrence, the properties, physical properties, chemical properties and uses. And also we studied about the nitrogen, the person who discovered why it is named so, as well as we studied about the occurrence of nitrogen, as well as the physical properties of nitrogen, chemical properties of nitrogen, as well as uses. And another topic is nothing but nitrogen fixation. The nitrogen fixation is very important for the plants, for growth, for their growth. Plants need nitrogen for their growth, so it cannot take as such as the nitrogen present in the atmosphere. It converts into the another form of nitrogen compounds, that is called as nitrogen fixation. So it is clear. I hope you just go through the lesson once so that it will be easy for you to understanding. So thank you boys, let us see in the next class.